Sanskritam and computing. What is the link between these two topics? Just like any other topic of public discourse in India, here as well there are two highly polarized versions. One set of people very liberally interprets and extrapolates that Sanskritam can be used as a coding language for computer programming. Another set of people who absolutely don't know a single word or even an alphabet of Sanskritam but kind of ridicule its scientific heritage. Forget about these two highly polarized versions. They are of no use for anyone. So we tried to find out what is the actual truth about Sanskritam and its relationship with computing. We found some very interesting facts which we're going to present in this documentary. We are presenting the facts, but if you're interested to challenge it, be our guest, do your analysis, do your research, and let us know if we are right or wrong. Sanskritam, being one of the oldest languages in the whole world, has some incredible contributions like binary number system. The foundations of it is originated from Sanskritam. Next, combinatorics, an incredibly powerful field of mathematics that deals with counting, which has applications in innumerable fields of science, is originated from Sanskritam. And the third field is computational linguistics, or the speech recognition. This is an area of research where Sanskritam is being studied for its linguistic properties, improvising the natural language processing techniques. We just chose these three areas of contribution from Sanskritam, but there are a lot many other as well. Here we are looking at Sanskritam only as a language.
Here is a verse from Bhavani Ashtakam, and hear me out reciting it. Na tato, na mata, na bandhur, na data, na putro, na putri, na bhrutyo, na bharta, na jaya, na vidya, na vruptir, mamaiva, gatistvam, tvameka bhavani. If you observe, the letters in black take less time to pronounce, and the letters in red take more time to pronounce. Let me repeat. Na tato, na mata, na bandhur, na data. You see that there is a wave pattern in the way the syllables are arranged in this verse, thus creating a rhythmic or a rhyming effect. The art of creating a poem by arranging the letters in such a rhythmic way is called as Chandas Shastra. Chandas is one of the 6 Vedangas that we saw some time back. Chandas gives the tone and tenor of the Vedas the way they are recited. In addition to Sanskritam, Kannada and Telugu also has this Chandas Shastra blended into the language. As Chandas gives the pleasant rhythm to the Sanskritam poems, it is metaphorically compared with Chand, which is moon, and hence the name Chandas Shastra. I will explain why we are talking about Chandas Shastra, but before that, one very important thing. Just like in music, where every song that we listen is an arrangement of 7 different notes in different combinations. Same way, every Sanskritam poem is a huge combination of short syllables and long syllables, or in other words, Laghu and Guru. The rhyming and beauty of the Sanskritam poem lies in how beautifully we arrange these short syllables and long syllables. Chandas Shastra, written by Pingalacharya, historically dated to be around 200 to 300 BC, gave certain algorithms to derive the way we can arrange these Guru-Laghu combinations in a Sanskritam poem. Here I refer to the book Chandas Shastra by Pingalacharya, a Sanskritam to English translation printed in 1874. Pingala gives 3-step algorithm as Dvikaglav, Misraucha and Prudagla Mishra. Let us see what they mean. Step 1 says Dvikaglav. That means there are 2 syllables, Guru and Laghu. As you see, Dvikaglav. Second step of the algorithm says Misraucha, which means mix themselves. Take Laghu and Guru and mix once with Laghu, and take Laghu and Guru again and mix once with Guru. Then you have Laghu Laghu, Guru Laghu, Laghu Guru and Guru Guru. And in step 3 it says Prudagla Mishra, which means mix themselves again. Basically repeat step 2. Take step to result, mix once with Laghu, and take step to result again and mix once with Guru. So that will give you Laghu Laghu Laghu, Guru Laghu Laghu, Laghu Guru Laghu, and so on. All these 3 combinations. Take this result set, and if we take Laghu as 1 and Guru as 0, this notation, this triplets what we are having here, is nothing but the 7, 6, 5, 4, 3, 2, 1, 0 of a binary number system. World's oldest written record of binary numeral system, Chandas Shastra, chapter 8, 20, 21, 22 sutras given by Pingalacharya. Now let me show you how to practically apply these algorithms of Pingala. If you want to construct a 3-lettered word as part of a poem. Let's say I want to write a 3-lettered word as part of a poem. I can write in a combination of all laghus. For example, na, ya, na, nayana. All 3 take less time to pronounce as they are laghus. Another possibility is Laghu Laghu Guru as Sa Ra La. Sarala. Another possibility is Guru Laghu Laghu like Bharata, and so on. Further in Chanda Shastra, Pingala says that the number of ways in which you can write a n-lettered word is 2 to the power of n. For instance, we can write a 3-lettered word in 2 raised to the power of 3, which is in 8 different ways. Same way, a 4-lettered word can be written in 2 raised to the power of 4, which is 16 different ways, and so on. This formula of 2 to the power n is the basis for expressing any kind of data in terms of binary digits of 1 and 0. The binary number system as we use today is credited to Gottfried Leibniz, a German mathematician of 17th century. You can see his paper here where he published the binary number system back in 17th century. However, mainstream academia admits that binary number system was well known to the people across the world centuries before Gottfried himself. While there is no written record about Leibniz getting inspired from Pingala's work, but those were the days when spice trade was at its peak from India to European nations. And not just wealth from India, but also the knowledge sources like these from India has also got transferred from India to Europe. And I'm not speculating that he got inspired from Pingala's work, but there is another written evidence about another branch of mathematics where Gottfried Leibniz shares the credit along with an Indian mathematician called Madhava. Check about Gottfried Leibniz and Madhava's infinite series. That is the foundation for calculus, and Madhava predates Gottfried Leibniz by hundreds of years. Unfortunately, the credit of calculus is given only to Leibniz and Newton, while Madhava predated both these mathematicians hundreds of years before, defining and disrupting the field of calculus. If you're more interested, read about the history of how binary number system originated, and you will end up with Pingala. This binary number system is the very basis for assembly level programming of your microprocessors, which is the very heart and soul of computing in the devices that we are using today, and the rest is history. Or in very simple words, the reason why your pen drives are only 32 GB and 64 GB is because of Pingala's 2 to the power of n formula of binary number system. And that is the link between Sanskritam and computing.
That's about the binary number system. Now let's see how Sanskritam contributed to the combinatorics. This is the most exciting and most interesting part of this entire documentary. Combinatorics is a field of mathematics that deals with counting, or decision making, or arranging things in a particular way. You probably know this with a different name called as permutations and combinations in your high school, which is used in fields like statistical physics to study the atomic behavior, evolutionary biology to study the combination of chromosomes, or in machine learning to study the exhaustive number of possibilities of making a decision. It is quite easy to understand combinatorics. Say you have 3 t-shirts and 2 jeans. In how many different ways can you dress up yourselves? It's quite easy. It's 6. Let's take a more complex problem. Imagine a cricket field where you have 25 common fielding positions and only 9 fielders, counting out the wicketkeeper and the bowler. So you have 9 fielders in 25 positions. And then you have right-handed and left-handed batsmen and right-handed and left-handed bowlers and round the wicket. With all these combinations, how many exhaustive fielding setups can we have? Don't try to count. It's going to run into lakhs and crores. For these kind of complex problems, combinatorics is used. Combinatorics is also used in DNA sequencing while studying human genetic variations. Like this, there are many other fields where combinatorics plays a very crucial role. All this is to help you understand how important combinatorics in different fields of science and technology. And now, let's see how it originated from Sanskritam. Let's take Bhavani Ashtakam poem again. Just like how we arrange the fielders on a cricket field to get the best result, same way, syllables are to be arranged in such a beautiful way that they sound very pleasant to hear. For this arrangement, Pingalacharya gave 6 algorithms: Prasthara, Nashtam, Uddishtam, Lagakriya, Sankhya, Advayoga. The first one, Prasthara, is what we saw in the binary numeral system. And now let us see Lagakriya, which defines the combinations.
We have to go back to Pingala's Chanda Shastra again. This is a lengthy algorithm and I'm going to cover directly in English. If you want, you can pause and read the word-to-word translation that is given in Sanskritam. First, draw 1 square, and just below that, draw 2 more squares in such a way that half of it overlaps with the above, just like it's shown here. And then repeat the process at the 3rd row again with 3 squares. And repeat the process again with 4 squares like it's shown here, and continue the process to a certain level. Say for example 4 levels here we assume. In the topmost square write 1, and then in the next level write 1 and 1 again, and in the third level write 1 in the extreme boxes and leave the middle one empty, and the middle one should be a sum of the above two. So here 1 plus 1 is 2. Same way for the third level, write 1 in the extremes and add the number above into the boxes, like 1 plus 2 is 3, 2 plus 1 is 3. This arrangement of numbers is called as Meru Prasthara. I was speechless when I first read this because this is called as Pascal's triangle in today's world. Written by Pingala back in 200 BC and reinvented by Pascal in the 17th century. I'll explain how Meru Prasthara became Pascal's triangle, but that's not the important point. What's rather important is to understand the mathematical features of this arrangement of numbers. Firstly, the name Meru Prasthara metaphorically represents the Mahameru Yantra of Sri Chakra. Let's not get much into this topic, but I'll briefly explain what it is in a little while. Let us understand why Pingala gave this numerical arrangement of numbers. Let's take a simple problem. Say if you have 5 coins, in how many ways we can get only 2 heads and 4 tails? In how many different ways can I get these combination? We can just write it down. We can just look up this Meru Prasthara table to solve this problem. We have 6 coins, so we have to go to row number 6, R6, and then the first box represents 0 heads and 6 tails. That's in one way. You can have 0 heads and all tails in just one way, so that's 1. In the second box says 6, so basically the 6 is 1 heads and 5 tails in 6 different ways. And the third one says 2 heads and 4 tails in 15 different ways. So the answer to the question is, it is in 15 different ways that we can get 2 heads and 4 tails. So basically Meru Prasthara is just a lookup table of numbers in terms of how can we play with different combinations. Now let's exactly replace the 6 coin problem with a 6-letter word. Imagine that you would like to compose a 6-letter word as part of a poem where you want only 2 gurus and 4 laghus. So you want a 6-letter word, just like the coin problem. Go to the 6th row, and then the third box is going to give you 2 gurus and 4 laghu combination, or vice versa. So that is in 15 different ways that you can write such kind of a word which has 2 gurus and 4 laghus. In the previous algorithm, 2 to the power of n gives you all the possibilities of writing a word. Here in a 6-letter word, 2 power 6 is 64. That means you can write in 64 different ways, irrespective of how many laghus or how many gurus are there. A 6-letter word can be written in 64 different ways. But if you specifically want 2 laghus and 4 gurus or vice versa, then this table is to look up and understand how many ways you can write that expected combination of laghus and gurus. And that is the purpose of Meru Prasthara. This is the worksheet of an unknown Sanskritam poet writing down the Meru Prasthara. Almost in the year 755, you see the combinations of guru, laghu, how they wrote to identify different words and their combinations. It was incredibly surprising for me to see this manuscript, which is 1300 years old. And this was way back in the year approximately 755 AD. This is 1000 years before Pascal, quote unquote, invented Pascal's triangle. Meru Prasthara has a lot of applications in different areas of mathematics. Here is one example, the binomial theorem. Meru Prasthara is nothing but the arrangement of the binomial coefficients. A plus b whole square is equal to a square plus 2ab plus b square. You see the coefficients can be directly read from the table. Same way for a plus b whole cube, and again a plus b to the power of 4. You can directly read the binomial coefficients from the Meru Prasthara. Another very important mathematical feature of Meru Prasthara is if you add up the diagonals, it gives out the Fibonacci series, which are in golden ratio. These series are called as Fibonacci series because an Italian mathematician, Fibonacci, in the 13th century wrote a book called Liber Abaci. This book is all about introducing Indian way of arithmetic operations to Europe. Thanks to Fibonacci, he really gave credit to Indians and he did not claim any of the work as his own. Fibonacci is the first one to introduce the Indian way of mathematics, or the Hindu numeral system, what the whole world is using today. He is the first one to introduce that to Europe. I will do a separate documentary only focusing on Liberbaki. But for now, let's move on. Fibonacci series is very special because we see it directly visible in the nature. For example, a sunflower arranges all its seeds in a Fibonacci sequence so that it can accommodate maximum number of seeds in its womb. Same way, a cauliflower also follows a Fibonacci sequence. It's a huge topic. If you're interested, read about Fibonacci series. And now you know that Fibonacci series came from Meru Prasthara. Like this, there are many mathematical patterns coming out of Meru Prasthara. Even till today, mathematicians are discovering new patterns with respect to Meru Prasthara or Pascal's triangle, which is more commonly called today. In Hinduism, the Sri Chakra Mahameru Yantra is revered as a symbol of universal motherhood and a source of energy. Sri Chakram is considered as the single source that disseminates different levels of energy. Metaphorically, Meru Prasthara also disseminates different kinds of mathematical patterns. Maybe that's the reason the names are alike. Anyways, let's move on. Now let's see how Pingala's Meru Prasthara became Pascal's triangle. He wrote it in 200 BCE. It was eventually translated by Omar Khayyam, a Persian mathematician in 11th century, a Chinese mathematician Yang Hui in 13th century, and Niccolò Tartaglia, an Italian mathematician in 16th century, and finally by Blaise Pascal from France in 16th century. This is a classic example of how the knowledge originated in India traveled across the world, contributing to the betterment of humanity. Let me be very clear on one aspect here. I'm not saying that the human intellect is a property of Indians. No, that's absolutely nonsense. My only point is the credit should be given to where it rightfully belongs to. Period. If we roll all the way back to Shiva Sutras, that's where we started. So Shiva Sutras gave birth to the 4 Vedas: Rig Veda, Sama Veda, Atharvana Veda and Yajur Veda. And these 4 Vedas are accompanied by 6 Vedangas: Siksha, Nirukta, Vyakarana, Kalpa, Jyotisha and Chamdas, written by Pingalacharya, in which he gave 6 combinatorial algorithms, of which we could cover only 2. And a couple of these were translated by different mathematicians across the globe, which gave rise to binary number system, algebra, combinatorics, infinite series and so on, and has applications in the fields of electronic computing, statistical physics, genetical analysis, machine learning and so on. So this is the end-to-end picture of how Shiva Sutras, which is the very basis of human speech, an art form, Sanskritam, which has given rise to all these mathematical and technological advancements that we are having today. This is no exaggeration. You can check each and every aspect of it for yourself. And there comes the third and the last contribution of Sanskritam to technology, which is in computational linguistics or speech recognition. Computational linguistics is a technology which deals with human speech recognition. Your Siri, Google Home, Alexa, all these are the voice assistants that run on computational linguistics. The very fundamental of computational linguistics is natural language processing. That means to understand what we are speaking, the machine should be able to understand what we are speaking and respond accordingly. This is an area where there has been some research on Sanskritam for its linguistic properties. There are certain linguistic properties of Sanskritam that sets it apart from any other language in the world. For instance, you can write Sanskritam in the shortest of the form called as a sutra format. So it is a ciphered format that you can write a huge message condensed into a very small format. Here is an example that we are seeing in Panini's Ashtadhyayi. The entire Panini's Ashtadhyayi is written in a sutra format. The rules are very condensed, at the same time very deep in its meaning. Also, Sanskritam has certain special properties, like it can create new words by fusing existing words, which is called as Sandhi. Like this, there are many properties of Sanskritam which are making it a special language to see how can we derive cues from its traits and make the natural language processing more effective. In the year 1985, a NASA engineer published a white paper on Sanskritam and its role in artificial intelligence, which is natural language processing. This is just an individual research but has no role of NASA directly involved as such, and probably this white paper is the root cause for all those baseless myths about NASA and Sanskritam. This white paper doesn't really hold any weight at this point in time. A more reliable source is in JNU, India. There is a department which is dedicated for computational linguistics of Sanskritam, and they have been doing quite some work. If you are interested, you can check the portal. Let us understand how human intelligence works. Your memories of the past plus your imagination about the future, these two will affect your decision in the present. This is a simple equation of how human intelligence works. Take a pause and think about yourself. Let me explain with a simple example. You want to decide whether you want to eat a chocolate or not. Your memory of the past tells you how a chocolate tastes like. It triggers a desire in you. Eventually, you will also imagine if you eat the chocolate, is that good for your diet or not? That's an imagination about the future. These two put together will finally help you take a decision whether you want to eat the chocolate at that point in time or not. And that decision of the present, good or bad, will become your memory and the loop continues. And this is what we call as human intelligence. So memory is very crucial for human intelligence, and that part of the brain which stores the long-term memory is called as hippocampus. Why I am saying this? There has been a research done on Sanskritam Pandits who have been memorizing and reciting Sanskritam slokams for years. Apparently, there has been a positive growth in their brain. Here is a research that was telecasted in Doordarshan in 2019. Take a look.
Extraordinary memory power of the Sanskrit scholars. How can they memorize vast texts such as Vedas and Upanishads as they are and pass it on to the next generation? Now, latest researchers have unraveled this mystery and named the phenomenon as Sanskrit effect.
Memorizing Vedic mantras enhances the brain regions associated with cognitive functions such as memory. The term
compare the two groups.
ब्रेन के कौन से स्ट्रक्चर्स हैं वो बदले हैं औरों के मुकाबले, और यहाँ हम देखते हैं कि जैसे हम लोगों ने सोचा था कि हिपोकैम्पस या मेमोरी का वो हिस्सा जो है वो थोड़ा बड़ा हुआ था.
Group of highly specialized memorizers and reciters of Vedic Sanskrit and of associated texts. Is there structural plasticity in their brains that's probably related to that practice? And we showed that for sure. We showed very dramatic differences in brain structure.
This is not a magic or something. We can easily break it down. Take a look at Shruti. This entire knowledge system is an oral tradition, which means the Sanskritam Pandits have to memorize tens of thousands of Sanskritam verses, read and recite them every day. Now, in which part of the world, in what kind of a knowledge system are people used to this kind of heavy reading, recitation and memory? There is no comparable education system which has huge amount of memory, reading and recitation like the Vedic education system. I'm not trying to undermine any other education system. I'm just trying to compare, saying that the intensity in memorizing and reciting is at its peak in Sanskritam, and hence the Sanskritam effect is there. This is what I understand logically.
As the outcome of the research proved that there is a visible growth in the brain structure, especially in the hippocampus area, which is kind of reservoir for your long-term memory, Gayatri Mahamantram metaphorically resembles the same. This is what it reads. Om Bhurbhuvas Vahatatsad Viturvarenyam Bhargo Devasya Dhimahi Dhiyo Yonaha Prachodayat. What it means is, metaphorically, Dhiyo Yonaha Prachodayat. It means empower our intelligence, wisdom, ability to think and act. Metaphorically, Gayatri Mahamantram is representing the essence of Sanskritam itself. If one can try to understand and analyze Sanskritam as a language without any kind of a political or religious or linguistic biases, Sanskritam stands high above any other language. In this documentary, we just focused on Sanskritam as a language, but if we start looking into other areas of knowledge like Kalpa, it has geometrical principles, Jyotisha, it has trigonometry and calculus based foundations, and Shilpa Shastra has geometry and mensuration, and Chandas Shastra is something that we just saw in this video. We have already made a lot of videos on Sanskritam and its relevance in these areas in our channel Project SHIVOHAM. The bottom line is, to understand the true history and heritage of India, reviving Sanskritam is the most important step, period. And as always, thanks for watching.